Hope my screen is visible to you. If you are responding, okay. Otherwise, I'll continue with my screen. Now we have 2 days, today and tomorrow is left over, and we completed, uh, you know, 3 blocks. Block one we completed, introduction to quality management. Yeah, introduction to quality management we discussed. Quality tools and techniques we discussed, quality implementation we discussed. Now we are going ahead with Six Sigma practices platform. So this today session and tomorrow session, I'm going to little bit fast because we have only 2 days left. I'm covering important concepts in the concepts. Have any queries, you can get back to me at any time. I'm ready to resolve your problems. Now, in this block, Six Sigma. So, introduction to Six Sigma and continuous improvement and DMAIC models. These 3 units it's covered under Six Sigma practices. What is mean by Six Sigma? Six Sigma. In generally, we'll call as like Six Sigma is the uh, thing zero defects, almost zero defects almost zero defects are there. Okay, so that is called as Six Sigma. Six Sigma. Now we'll go ahead with this Six Sigma and definition. Now what happened in Six Sigma? If we implement, whenever we are getting a zero defects and there is a quality in that. So Six Sigma is a quality enhancement, problem solving process, improving methodology, also methodology, implement quality, total quality management, and innovative approach, continuous improvement. Six Sigma is universal scale like stick to measure, uh, stick measuring inches, a balance measure, measuring ones. So this is called. Now we'll moving towards first unit, introduction to Six Sigma. Six Sigma provides the companies with a series of intervention and statistical tool can lead to breakthrough profitability, quantum gains in quality, whether products of a company are durable or services. Six Sigma is powerful, rigorous, data-driven, customer-focused management dealing with defects. Already we discussed defects, services, delivery, and training of champions. Black belt, green belt, black belt and green belt. Sigma is a letter in the Greek alphabet used to statistic representation of standard deviation. Standard deviation is nothing but risk, indicating the degree of variation in set of measurement or process. Standard deviation measured variation or amount of spread process average. Now here, Six Sigma concept is measure the process in terms of defects. Terms of Six Sigma is about the practices that helps to eliminate the defects. Always deliver product and service that meet the customer expectation. That's very important. Customer expectation and specification. The central idea of Six Sigma management figure out the systematic ways to eliminate defects and approach the quality levels zero defects. So there is approach Six Sigma that's called DPMO. We'll see later, DPMO. And it is implemented in this total quality management. What do you mean by DPMO? Defects per million opportunity. Defects per million opportunity. Number based on number of items are defected. If you take a sample size of 1 million opportunity, DPMO. Now we can see here luggage. So loss of luggage at airport. So if you take that 10 lakhs, 10 lakhs, that is 1 million. So here, that, 66,000 defects, that is approximately 94% of, accuracy will be there in luggage. So that's called 3 sigma, 4 sigma, like that, based on the level, DP, MO level. Okay. Now we are going to see what is meant by Six Sigma. Six Sigma is an improvement approach and improvement program. A complete definition of Six Sigma state that it is an organized parallel, some structure to reduce variation in organizational process by using improvement specialists. A structured method, performance metrics with the aim to achieve strategic objectives. Overall, Six Sigma is a defect rate matrix considered the high quality of standard. Six Sigma is part per million. Again we call as, which express part per parts per million. So if you take 1 million, how many parts they are going to defect? That's also we call as. There are some key elements of Six Sigma. There are key elements of Six Sigma. One is critical to quality. Critical to quality. What exactly it means? Critical to quality. One second. Yeah. Attribute most important to customer. Defects, failure, or deliver what customer wants. Next, process capability. So what your process can deliver. Variation, what customer sees and feels. Stable operation, ensure consist of a detachable process, improve what customer sees facts. Six Sigma, is benefit a process. Next, difference between 3 and 4 Six Sigma. Now you can see here, Sigma is a 6 quality. So first 3 approximate 3 Sigma level, and 1.5 is misspelled words, page number book. Now here, Six Sigma, 6 qualities. There are 6 qualities are there. Equivalent misspelled word almost. You can see 1 to 6. 6 qualities are there. You can see here. So magnitude and difference between Six Sigma levels. That is area, spelling, time, distance. Sigma level 1, floor space of the astronaut. No floor space. Next, 170 misspelled word per page. That is 31.3/4 years per century. So this is misspelled. So from here to moon, the distance. This is level 1. We'll call as. No, level 2, floor space of large supermarket. It can be counted. 25 misspelled word per page in a book. Okay, good. 4.5 years per century. Then 1.5 time around the world. Okay. Then third level is floor space of the small hardware shop. That is 1.5 misspelled per page. No, level 3. 3.5 month per century. That is time. So coast to coast trip. Then floor space of typical living room. One misspelled for level 4. Once misspelled per 30 pages. Not single page. 30 pages. Typically book chapter. 2.5 day per century. Days is century. Days is also reduced. And 45 time freeway driving. Then size of the bottom of your telephone. It's very narrow space. One misspell set of encyclopedia. One misspelling. Okay. 30 minutes per century. It's going to reduce. One trip local gas station. It's very narrowed down. And 6th level, size of typical diamond. Diamond is very small, Okay. One misspelled word, all the books in small library. You can see one misspelled, all the books, one small library. 6 seconds per century. It's minute. 4 step in any direction. Okay. So starting from Earth to moon, now 4 step. You can see the difference. The point of swing needle. Needle. What is the point? No, needle point is there, right? Okay, that point. One missed word in all the books, several large library. That's very important. One eye blink per century. Eye blink. It's a fraction of second. Now we are going to travel inch. Now you can see here that is courtesy by Texas Instruments. So here, no difference between sigma level. So that is a sigma level effects. Okay, we are going to see here. Next, Motorola is also implemented Six Sigma. So in Motorola, what happened in 1986? Motorola invents Six Sigma, committed to continuous advantage of Six Sigma. Motorola Six Sigma experts invited to contribute their experience inside. So in 1987, that is the first set of ambition Six Sigma goals. Motorola sets the goal reaching the level Six Sigma more than uh, more than reaching the sigma level more than 3.5 defective per million. Okay. And then Motorola receives the normal quality award. Motorola efforts award they received and recognized by McCallum Balbridge National Quality Award, highlighting the organization committee and customer quality. So in 1991, which is first Six Sigma black belt is achieved by Motorola. Okay. Then 1992, the other leading organization began adapt Six Sigma. Six Sigma adapted beyond the manufacturing many prominent cost and industries from financial services, transport, high tech. They are introducing. 1999, what happened? Motorola University offers Six Sigma consultant training services. Motorola extended beyond its own value chain, helps to organization all shape, size meet their objective, continuous business program imports. So the new Six Sigma evolves from metrics to a methodology management system from driving business results. So here, Motorola wins nationally recognized Malcolm Balbridge National Quality Awards second time, and 2002 offers a green belt and black belt certification of Motorola, trained thousands of Six Sigma green belt and black belts for every certifying that professions. In 2003, what happened? So Motorola continuous innovative using the renews its Six Sigma efforts with new advancement restructured deployment, cost of poor quality, it's going to be is no in 2004 Six Sigma efforts rewarded against Six Sigma helps Motorola 42% revenue growth, increase 25% in earning per share. Or okay, so 2005 Motorola experts speaks international conferences, committees to control advanced Six Sigma. Motorola Six Sigma experts invite the contribute their. No, here, this is the story of Motorola. You can see, you can read it. And opportunities for Six Sigma. So, what are the opportunities? So, once we are going to be observe that there are several opportunities available implementing the Six Sigma. One is reducing the manufacturing cost. Of course, we may reduce manufacturing cost, increasing production per day, increasing sales, reducing new product development time, reducing delivery delays, and eliminating the package labeling or errors, creating designs accepted better customers by customers, enhancing buyers, dealers, end user satisfaction, and enhancing repeat sales, repeat business, and reducing inventory variability within batch production, reducing rejections, reducing accounts receivable, and increasing tender or code acceptance, reducing turnaround time and model for many and more. So these are the advantages are there. Now you can observe the process. I said DPMO, right? Earlier we discussed DPMO. So defects per unit. So one defect, you can see here, sigma level 1. So if you found 1 million, that is called 1 million per million. So it's 30%. And if you found 3 lakhs, 69%. Now it's reduced to 366, that is 93.3. Now you can see 4, 6,099 point. If it is 5, 223, that is 99.98. If it is sixth level, 3.4 per million, okay, per million, it's 99.99997. So you can say it's zero defects. So how we can calculate this Six Sigma? Now you can see loan application, 250 loan applications are there, n number of units. And defects, 43 defects are there. Population. So if P is equals to a capital X divided by N, 43 divided by 450, that is 0.172. Percentage, 117.2. Yield, 1 minus 82 point. No, yield percentage. This is called. So loan application. And then they have advertisement contract, advertising. Then manufacturing. So microchips, so defects and steel. Okay, it's defects. Now you can see here, based on the yield, we are going to calculate this. So there is formula called number of units, number of defects, proportion, percentage of P, and yield 1 minus P. We'll calculation of yield. Then statistical definition. So we know sigma is the Greek letter representing the standard deviation. So from the mean, Six Sigma methodology provide the techniques and tools. It was started in Motorola and manufacturing defined, where millions of parts are made using the same process repeatedly. Same process repeatedly. Okay. Evolved applications, non-manufacturing process. Today, can apply Six Sigma in the field of services, DMIC. So DMIC, we can see here DMIC, define opportunities, measure performance, analysis opportunities, improvement performance, and control. So here, DMAIC is going to be very important questions in external examinations concerned. You can prepare well. Okay, advantage of Six Sigma. So cost reduction, unnecessary cost. Already we discussed, and financial saving, enhance customer satisfaction, improve quality, and positive growth, positive impact. So here communication and education skills. So here advantages are there, self-sustained infrastructure and training material, tools, software, and disadvantages are most time quality standards will depending on type of operation and job involved, always aiming Six Sigma standard, not bringing considerable. I can see these are the specifications. So you can see here upper circuit, upper specification limit, lower specification limit is there, and TCQ is there. CTQ is and fixing lower specification. Okay, now you can see CP is equals to UCL minus LCL divided by 6 sigma. Now control limit versus specific limit. LCL and UCL mean upper control limit, lower control limit. This is the table. This is the table. X, UCL, and metric performance. You can see defects. It's going to be used. Excuse me 1 second. Give me 1 minute of time. I'm back. Sorry. Okay. Now normal distribution. You can see normal distribution is also we are going to consider probability density function. So here random variable x and normal distribution, that is mu, mean, that is variation, sigma square and variation. You can see here. So here y is equals to function of x 1 divided by sigma square root of 2 mu e minus square root of minus 1 by 2 x mu. So that is infinity minus infinity, x in between, x positive, that is minus infinity to positive. Now mu is equals to 22 by 7. You know that it is a constant value. E is equals to 2.713, that is based on normal. Mu is equals to mean, so sigma is the variation given, so normal distribution is going to graph. Now you can see here like this parabola is going to be happening. So standard normalization, z is equals to z, no, not random value rv is equals to rv is there, and statistical normal value snv is there. Z is equal z equals x minus mu divided by sigma, and x, you can see here. And statistical normal deviation probability function, f z is equals to 1 divided by this is also z is also minus infinity negative. So properties of normal distribution, and distinct between binomial position and binomial distribution. Are we distributed? Are we associated with the normal curve? And normal curve is systematic above mean, that is skewness is equals to 0 and foldable. So these are the things you can read it. So this is the diagram. 68.67 probability. It is in between left side and right side, and 95. So it's almost end value. And then 99, it's almost close value. So here 2 sigma, here 3 sigma. Okay. Then 5 sigma, 6 sigma is also there. Okay. So importance of normal distribution. Normal distribution has a great significant statistical uh, data analysis because of this following reason. Normal distribution has a remarkable property stated in the control limit theorems. X1, X2, Xn, independent and identical random sample, and mu and standard deviation. Simple x bar is also normal distribution. Mu is also standard error. Mu divided by square root of n is result. So even in a variable is not normally distributed, it can sometimes be brought to normal form by simple transformation of variable. For example, distribution of x skewed and distribution of square root of might be normal. Many of the sampling distribution like ST, skew under F, also tend to of normal distribution. The sampling theory tests significant are based on the assumptions in the sample drawn the normal population, mu and variation sigma. Here you can see here the normal the normal's law of error standard out in the experience of market as one of the broad generalization of natural philosophy. So they are guiding to instrument the repeated physical and social sciences and in medicines, agriculture, engineering is in. So you can see here Six Sigma performance, how it can be performed. We are seeing this performance Six Sigma defects. Okay, Six Sigma. What is Six Sigma performance? You can see here 1 sigma defects, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma. So 6 sigma, total 6 sigma. So 1 sigma here, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma. So depends on the level percentage. We can draw this. You can remember 68, 95, 60, 68, 68, 95, 99.73, 99.9937, 99.99943, 99.99998. Like that. You can remember this Six Sigma training. So belts and benefits. Organizations implement the belts. There are two belts, green belt and black belt. So implementation techniques. Okay, here on the job training and it's required. Now belt system in Six Sigma. So belt system Six Sigma, white belt, yellow belt, and green belt. What is mean by white belt? White belt. First level of Six Sigma knowledge is white belt. And yellow belt, Six Sigma yellow belt is professional who is versed basic of the Six Sigma methodology, support the importance of project part of team and conduct small projects in the part of basis. So it's called as yellow belt. They are using DMC. So DMC here. Okay. Green belt. Green belt belts are employees organizations who execute the Six Sigma the overall jobs. So Green Belt Six Sigma teams member receive the 2 weeks of training, including project orientation. So devote 25 to 40% of the time to Six Sigma projects. So Black Belt, then Black Belt, a specific Six Sigma term described to team leader. So achieve a accurate Black Belt and qualification after 4 hours of 4 weeks of training. Full-time employees and directly involved in the implementation of Six Sigma and project leader and master statistical analysis and process improvement. Critical to the success, black belts is the on-site support of the experimental master black belt. Then Master Black Belt. Master Black Belt, highest Six Sigma belt ranking. So here, highly qualified Six Sigma practitioner identify the champions and act in-house coaches Six Sigma concern the overall Six Sigma activities from the organizations. So apart from statistical tasks, they spend time ensuring the consistent applications of Six Sigma across the various functions department, devote 100% of the time Six Sigma. So play a critical role in communicating with seniors, executive to gain support. So next, finally, champions. Champions are committed to Six Sigma, promote and throughout the organization, fight for the cause and for black belt and remove the barriers and task responsibilities. So there are belts, 6 kinds of things are there: white belt, yellow belt, green belt, black belt, and master black belt, and finally champions. So benefits are it's benefit to organization and suppliers, and it benefits to individual customers. So it is help to all types of customers. You can read this, and we have suggestion of reading, have some kind of case study is not there in this unit. Okay. Next unit is continuous improvement. How we can get continuous improvement? How after implementing Six Sigma, continuous improvement is going to be happen. So once you found any defects are not there in your product, definitely it's going to be continuous improvement. And we can identify projects and evaluate the stages of project and role of business management team. Identify project, balance scorecard, design the Six Sigma. So here it's very important of considering the quality building organization. It's all the improvement quality and product while getting the manufacturing process underway. So towards building Six Sigma quality in the manufacturing process or even service quality, systematic and continuous plan of action is required. The following active discussion is, you can see here, implementation of Six Sigma. Once we implementing Sigma, what happens? Step one, project identification. So identify the product, create service, create or service the your provide. So identification of CTQs, customer technology quality requirement. So here, so identify customers, your product or service, determine what considered important. Now identifying measurements, identify needs or satisfy the customers and provide the product or service, vice versa customers. So determine the converted into technical specification called CTQs, followed by obtaining data quality, quantifying the determining. Next step 4, implementation of Six Sigma. Two methodologies, namely DMIAC. Already we are seen DMAV. So here Motorola example DMAC and defects per achievement. So C okay no defect we have seen. So DMV defect measure, analyze, design, and verify. So so verify is going to be coming here. Verification. So DMA is used to process new have implement the organization. So here IDOC is going to be happen. So IDOC is nothing but identify, design, and optimize and validate. So step 5 is mistake proof. So there is no mistake elimination of waste effort. And step 6, ensure the continuous improvement by measuring, analyzing, controlling improvement process. So it's going to be happen in step-by-step process, implementing Six Sigma. Now, continuous improvement. Now here, continuous. How we are going to get the continuous improvement? Once they are implemented in project stages, it's going to be continuous improvement. Now, already we have seen that define, measure, analyze, improve, and control. So DMAIC. Next, project identification, financial and strategic benefit, improved customer satisfaction, capable with the current goals and objective, translatable and other areas of probability of success. Now, here after if benefits, strategic fit and revenue growth and cost reduction and capital avoidance. So there are personal needs, length of projects, and capital cost, risk of operations. Evaluatory stage of project. So there are properly scoping the prioritizing existing opportunity in the organization, set criteria for project and selection, brainstorming new ideas for projects, add rigorous and process by sourcing existing data, sources knowledge base, rely on the value stream, mapping tool, identifying the highest impact project. So the role of business management team and identification of projects. So bottom-up approach and top-down approach. Bottom-up approach means nothing but ideas generation from existing project of the employee. Top-down approach, ideas generation from the start from the corporate priorities, that is top-level management to low-level management. So here, comparison between bottom-up and so there are bottom-up good mix of quick hits project and allows the wide audience and self. No, we are getting the ideas from the top, bottom level to top. So cons. So bias towards already knows and trends surface pet projects and typically not driven, supported by data. Many ideas are there persistent paying. So top down. So in here link is the strategy and goal. So NPV involve the fresh eyes approach. Get outside the department box. So new insights generated. So here requires a new diagnostic process and champions must learn, execute educate others. So these are the things. So top down project identification strategies, unlimited strategy filter through which activities must plan. Pause strategy shine light that have no process this thing. So financial one, so financial and profit and loss line and Pareto analysis drivers and tactical business growth, revenue growth and operation growth value. Then balanced scorecard. So here scorecard we are going to give points. So there are visionary statement. So in that visionary statement, so customer are there, internal business process is there, learning growth is there, financial aspects is there. So here objectives we are going to give messages, measures and targets integrative. So to achieve the vision and strategy we are going to give that points. So internal business process, so objectives, measures, trainers. So each and every aspect, objectives, measures, targets and initiatives. So we are going to write it down all those things and we are making the scorecard. Balanced scorecard which promote the organization governance and based on the set of driver that's implemented matrix in the project identification. Balanced scorecard guided examination through this strategy, financial, customer, and process. So there are existing strategy lens, financial analysis lens. So these are the things. Design for Six Sigma. So here transactional Six Sigma. So what is the transaction? Transaction Six Sigma focus on operational. Transaction is nothing but operation. Operation is the excellence. Customer satisfaction and cost reduction with all components and operations. Areas focus include sales, HR, finance, and materials, etc. And production Six Sigma. So production based focus on product production excellence, variation and defects reduction, lean production techniques, customer satisfaction, all those things. Analytical tools for implementation. So process mapping and modeling. So measurement of this system, analysis process capability, brainstorming, design of experiment, FEMA of and validation statistical things. So typical workflow here, test order and sample registration, sample preparation, task allocation, sample testing, and result analysis, result validation, certification analysis, COA, and billing process. Next, brainstorming we are going to do. So by using then statistical control charts we are going to use. So next, Kaizen. Kaizen is also very, very important. Kaizen is the continuous improvement. Kaizen emphasizes the creative for before capital, and Kaizen is an incentive rapid improvement model. So training, discovery, analysis, and assessment. So these are the four components: training, discovery, analysis, and assessment. So TAT, that is called time. So net time available, and brainstorming and implementation, standardization, results, follow-up, parking lot, and presentation. So these are the Kaizen, uh, no, Six Sigma practices. I can see here. Uh, Background approaches, okay, distributor, proposal process, okay. So the Kaizen is going to be talked. So Kaizen visual managing workflow level, namely individual, team, organization. It processes the Kaizen Dan. So this system translate the original Japanese visual signal. So here, visual signal are called. So the Kanban originally conceived by Japanese car manufacturing company Toyota. So in 1940s. So here, Kanban is the first time the cards were in the form of paper pinned in physical boards. That is Kanban board. In around 60 years of later, David David J. Anderson took the original idea of set of Kanban method functions knowledge to one. Now, then Kanban code, it's called as can is nothing but visual, chord is nothing but band, Kanban. So what to do? Now you can see here. Now this is a Kanban board, visual effects, uh, and to do doing 10. So there are nowadays there are a lot of tools are there. We are going to use this Kanban tools like Notion, Google Drive. Okay, in Google Notion. So work in progress, completed, to be done, and assigned to. Okay, so there are lot many tools are there. Okay, uh, they're going to use. And JIT, just in time. So just in time, what is mean by just in time? So here, products coming to warehouse at right time. So describe the operational production method based on the minimizing stock level. So here, minimizing the stock level. Stock level is going to be reduced. Aim to which reduce the capital employed stock, in which also known the benefits, reducing the storage space and decreasing the dependency on the logistics, easier supply chain, better overall quality. Shift is actually capability of rising from improvements and without improving efficiency and reliability. Okay. Now, even then, so absolute minimum or even zero, it allows the room of error timing. So this is how JIT, and these are this unit. You can read these questions. You can see here acronyms DMOP. So CTQ, critical to quality, VOC, voice of customer, DMVC, define, measure, analyze, and design or verify. IC is nothing but improve and control. IDOC, identify, design, optimize value. So you can see here. Next unit is DMAIC. Now this time I'm moving towards a little bit fast. Have any questions? You can stop me, sir. I don't understand this concept. I'm going to explain this. Okay, DMAIC. Here DMAIC already we discussed in earlier chapter. Okay, so DMAIC. There are metrics are there. Process is there. Six Sigma. Roles and responsibility. Roles required to Six Sigma implementation. Selection of project. Okay. Uh, then guidelines, guidelines for DMIC. So here, get leaders involved in the first thing. So leaders should be involved in DMIC. Since the set company strategy, they need to be involved how the metrics linked to achieving it. Six Sigma initially will require company-wide commitment, human, other prospects. Visually represent metrics. uh, prominently display them in chart, graphs, and diagrams. Metrics must respond quickly. So measurement of system must provide feedback immediately. Okay, immediately. Promotely so that it can be identify the problems correct soon. So metrics must be simple and limit to the number of metrics. So take corrective action. One of the feedback of the collected from this action. So DMAIC. So first D for define, measure, analyze, improve, and control. Define, measure, analyze, improve, control. DMA, DM, DMAIC. D for defined, M for measure, A for analyze, I for uh, improve, and C for control. So here there are seven phases are there. So here phase define is the first phase. Define. In the define phase. So what are the things we need to define? Activities. Identify the project champion, project owner, determine customer requirement, CTQ, and define problems, objectives, goals, map process, and quality tools, project charter, and plan, effort, implement, analyze the process management. So in define phase, these are the involvements are there. You can see here, uh, credit agency, suppliers, inputs, process, outputs, customer. So here, suppliers, credit agency, mark office production, inputs, credit reports, and proposed lease thing, process, customer credit review, equipment validation, and preparation of document, funding, billing, and output. So lease agreement is going to be happen and payment is going to be equipment laser and marking. No, SPIOC is diagrams. SPI, this is called SPIOC. SP, SP, sorry, SIPOC. SIPOC. So suppliers input, SIPOC, process and customer. So here, next measurement phase. First, D is over M. In measurement phase, we are going to measure. So determine the project X and Y, criticals of X, and determine operational definitions, establishment of performance standard, develop data collection and sample plan, validate measurement system and analysis, determine the process capability and baseline, quality functions, data deployment, measurement system analysis, check sheet, and process capability. So these are the measurement stage. Critical criteria for business metrics, guidelines for metrics, get leaders involved and visually represent your metrics. Metrics must respond quickly. Metrics must be simple and limit the number of metrics. Take care. So analyze phase. A. DMA. So here third phase is no establishing process baseline. How determine process line improve the goals. Now, acknowledge discovery, including the descriptive and exploratory data analysis finding. The basis of a principal statistical SPC is going to happen, and control correlation regression analysis of things, then activity, benchmark the process product, statistical analysis, and establish causal relationship using analysis of process map. So here, determine root causes, statistical control going to be used. So here, they use some kind of tools, SWOT analysis, process mapping, tree map, tree diagram, Pareto, so fishbone diagram, 5-way, 5Y, and tree diagram, intercorrelation diagram, resource utilization, customer services, overall equipment efficiency, time series plots, multivariance analysis, histograms, scatter diagrams. So these are the things we are going to use in this. This is an example, counts, non-core carriers, missing codes, and incorrect discussion and incorrect code. So then it can be done. Then is another fish diagram. Is example of fish diagram. It's a fish diagram. You can see here generate the general district human resources of patients and the registration process facilitating and long term. So this is called fish diagram and root cause analysis. Root cause why Five whys. Why? Battery is dead. First why. And second why is alternator is not functioning. Second why. Third why is alternator belt has breakdown. Third why. So the fourth why is alternate belt as well as well beyond the useful services is not replaced. Fourth why. So fifth why is the vehicle was not maintained corrected according to the recommendation services schedule. Fifth why. So why routes schedule. The next histograms. You know the histograms is going to be happen. Next, scatter diagrams. Scatter diagrams also you people are studied in statistics. Then next, improved phase. So in the improved phase, activities are there, quality control. Develop solution alternative, access risk and benefit solutions, validate solutions using pilot and implement solutions, determine solutions efficiency. So quality tools, design, experiment and brainstorming, FEMA, failure mode effect analysis, risk assessment. Tools utilized in phase. So regression analysis, hypothesis testing. Okay, there are null hypothesis and alternate hypothesis are there. Okay, and then design of equipment. So in this, we have determined the relationship between factors affecting the process and output that output process. The other words they use to find the defect cause and effect relationship. And analysis of variance, ANOVA. ANOVA is a hypothesis that means the two of more population are equal. ANOVAs access the importance of the more factors that comparing the responsible variable. 5S are there. 5S is nothing but CC, that sort, sector, that is strategic arrange, say so, and second, and this is the things. And mistake proofing, normal group of techniques, single measurement and seed, value streaming, brainstorming, and mind mapping. So this next, control phase. Control phase. So measurement phase, we are going to use so many measurements. So many measurements are there. Histograms. So you can see the tools and techniques. You can see SWOT. Okay. So WISE, hypothesis, regression, time series, multivariance analysis, and histogram, scatter diagram. So many tools are there. We are going to use in measurement. After that, we are moving after measurement. DEM. C. C means control. Control phase. So here, activities determine the needed to control, that is measurement, design. So statistical control, process control, implement and validate control, out of control action plan, develop transfer plan, design change to eliminate defects, close project and communicate results. These are the things. Design digital Six Sigma DMAC implement. Now here, objectives, main activity, potential tools and techniques, and key deliverables. You can see each and everything. So here, potential tools and techniques. So objectives, main activities, key element. You can see here. Next, Six Sigma. EMES. And Six Sigma roles and responsibilities. Six Sigma qualification. So that is champion, senior executives. So there are green belt. We're not talking this white belt, yellow belt, green belt, black belt, master black belt, champions. So qualifications are senior executives such as vice president, directors, head of the business, and units must have familiar with the basics and advanced statistical tools. Master belt, chief engineers, technical heads, master of advanced statistical tools they need to learn. So black belt, technical degree or oriented preference must have high growth potential, have organization must over the statistical tool necessary. Green belt, project heads and process owners, technical background preferred must knows. Training training time, 1 week, 2 weeks, 1 week is required to 1 in 1 week training. So for 1 week training session or 2-3 days session. Okay, so between sessions are applying here. So number per company. So one business group. So one per 30 black belts. So one for 100 employees, one for 20 employees are there. approximately amount of savings. So not applicable here, 50 lakhs. Depends on the project they are going to say. Then roles required Six Sigma implementation. Okay, so the term Six Sigma orientation, Motorola, where the Six Sigma methodology was developed and refined, and eventually, so the approach was adapted and expanded upon the other organization terms where coined the Motorola elsewhere that describe various roles in the Six Sigma process. To avoid the controversy conflict over the use of some of these terms, you can see here champions, what they're going to be functions of champions. Champions are uh, executes with the significant moral business to set the vision, to create the mandate for improvement, initiate and fund activity, establishment of maintain the reporting, to communicate the version, and to provide the direction, remove the barriers, and achieve the financial results and commitment success. Responsibility of champions, 10% of time. Identify the champions of each functional area, each functional area to monthly uh, uh, to monthly review of project, to measure the champion results, to identify black belts and green belts, to identify approve of all Six Sigma project, to bi-weekly review the project, and master black belt, what they're going. So what master black belt is expert in Six Sigma techniques. So the application they're playing. So function of master black belts to improve the technical expertise Six Sigma tech. So work with support and a black belt champion, responsibility of master black belt 100% of time. Black belts. Black belts are a process implement team leader who is trained, certainly certified in Six Sigma methodology, tools and responsibilities. Functions of black belt. So to work improvement of project with other green belt team members to achieve the financial for each project responsibility, black belt, 10 to 100 to 20% of this time. Okay, use DMAIC methodology breakdown to performance and report the report progress champion, and hold team meetings and provide the excellent project management. Responsibility of black belt. Use DMAIC is methodology create to breakthrough in performance, report the progress the champion, hold team meetings and provide this to work with the master black belt. So next, green belt, similar black belt, but they do not have full time role, and uh, to spend 10 to 15% of time with projects. So difference between champions and supporter. So here champion recruiters new support Six Sigma. So supporter is maintains support of the Six Sigma and anticipate the address Six Sigma problems before they occur. React and to help the solve the Six Sigma problems that occurs. Speaks inspirationally about that Six Sigma, speak supportively about Six Sigma, and actively seeks the permission, opportunities at show, and avoid that public action and which appears non-supportive of Six Sigma. And these are the participate in the planned Six Sigma. So these are the things are there. Then selection of a project for Six Sigma. So here financial strategic benefits, improve the customer satisfaction, and complicated with the current goals and objectives, translate the business probability of success, level of efforts, amount of sources complete. So let me sum up this and define measurement phase, control phase, operator phase, and definite goals. Next model, you can see, you can read the model question papers. Okay. So with this, the block 4 we are going to complete in today's session. So next, block 5 is all about implementation of TQM, where that quality can customize customer expressed improvement. So QC. So here TQM in service sector and quality culture leadership. quality centered planning. So these three are there. We are going to see in next class. Okay. With this, we are going to close today's session. Okay. Thank you. Thanks for your time. Have any question? 3, 4 more units are there. You can see. Have any questions? Think Kalyan, have any questions? Meanwhile, 3 minutes we are going to discuss the questions, important questions uh, for real-time scenario is concerned. You people prepare that self-assessment questions are there. You can prepare what is Six Sigma roles and responsibility. Explain roles required Six Sigma implementation. You can read this and you can study this. And there are keywords they mention in the uh, end of the section, and short answer question, long answer question also. You can create suggestions. You can, if you want, you can improvise these suggestions. So with this, today's class, I'm going to stop here, and we'll see you next tomorrow at 11:30. Thank you. Ambedkar team, it's over to you. Kalyan, do you have any questions? Please feel free to ask. Now, you don't have any questions, we'll wind up this session. Think there is no response. Kalyan? Okay. Okay, thank you. Ambedkar team, it's over to you. Ambedkar team, it's over to you. Okay, thank you. I'm exiting the meeting. Thank you so much.